Now, rough sketch of the root locus for this particular problem. Rough sketch. Two axes is there. One is real axis, another is imaginary axis. Now, the location of poles. Poles are located at 0, -2, -1 plus 4j, -1 minus 4j. So rough sketch is important. Mind it, this is the rough sketch. This is not the final sketch. Rough sketch. Why rough sketch is important? Rough sketch is important here because without any rough sketch, we cannot predict what are the parameters the root locus contains. Now, this is -1 plus 4j. This is -1 minus 4j. Root locus always starts from its respective poles. So there are 4 poles here. So there will be 4 root locus. So the root locus which starts from 0, it will terminate at infinity because there is no 0 here. So the root locus which starts from this pole, it must terminate at 0. Whether it will go left side or right side towards infinity, that will be determined by the section analysis, what I have previously discussed. Now, for the section analysis, take the left hand side section of this pole. Now, for this particular section, to the right of this section, the number of poles is 1 here. It is taken into account. 1. 1 means the number is odd. That is why it is section of the root locus. If it is not the section of the root locus, then root locus doesn't go in this direction. For this particular problem, it is the section of the root locus. So root locus must go in this direction. Now, for this pole, the root locus which starts from 2, whether it will go left side or right side towards infinity, that will also determined by the section analysis. Take the right hand side section of this real axis. So right hand side section, to the right of this section, the number of poles plus number of 0 is 2 here, because 1 and 1, that is 2. 2 here, 2 is even number. So that is why it is not the section of the root locus. So root locus never go in this direction, it will go in this direction. So now the collision will occur because 2 are coming face to face. So collision will occur. That collision is when occurs, a breakaway will create it like this. So what will be the magnitude of the breakaway? We will find out later. Now, for this particular pole, now let's draw the asymptote of the system. So centroid means the intersection points of the asymptote on the real axis. So previously we have determined the centroid point is -1, located at -1. So let's start from this point to draw the asymptotes. So for the first asymptotes, it makes an angle of 45 degrees with the real axis. So try to draw the asymptotes which is 45 degrees with the real axis, like a dotted line, like this. So from this property of symmetry, we can say another asymptote will must lie in like this. So it will makes an angle of 225 with the real axis. For the next asymptote, it makes an angle of 135 degree with the real axis. Now, draw the 135 degree angle, and the asymptote is like this. So by the property of symmetry, last asymptote will lie in this direction. So it must follow the symmetrical property. If you fold the total graph through this horizontal axis, now it will make a symmetry. So that is why the 4 asymptotes will be located like this. Now, for this particular poles, which the root locus starts from the poles of -1 plus 4j, must follow the direction of the asymptotes towards the infinity. And also it is must follow the direction of the asymptote to the infinity, and after breakaway, two parts of the root locus which terminates towards the infinity will go along this asymptote towards infinity, and this is along this asymptote towards infinity. This is the rough sketch of the total root locus. Now, what are the parameter occurs in this particular problem? So, for the first parameter is breakaway. The next parameter is imaginary axis cutting point. Imaginary axis cutting point and breakaway. And last of all, angle of departure. And what is angle of departure? Angle of departure. Now the angle of departure. What is angle of departure? Angle of departure is that angle through which the root locus which starts from this complex pole will go towards infinity, will tangentially go towards infinity. This is called the angle of departure. Now, let's find out the three parameters. One is breakaway, next one is imaginary axis cutting point, and third one is angle of departure. First parameter is angle of departure. Angle of departure, there is del equal to now let's start to find out the angle of departure from pole -1 plus 4j. So it is your reference pole -1 plus 4j. Now the angle of departure from pole -1 plus 4j, the formula will be, if it is pole to pole, then negative, it will start from negative sign. Negative of sine angle reference pole -1 plus 4j minus of next pole, that is minus of -2. And next one, for this pole to pole, it is clear. Now next, for this pole to pole, minus of angle -1 plus 4j minus of 0. Next, minus of angle for this pole to pole, -1 plus 4j minus of -1 minus 4j plus 180 degree. This is the basic formula to find out the angle of departure. Now, if there is 0 in this system, then it will start from plus sign. Plus of, suppose there is a 0, in this system here. Suppose 0 is located at a -3. So for this particular, from this pole to 0, it will start from plus sign, plus of angle -1 plus 4j minus of -3. So this system doesn't contain any zeros, so the ultimate formula will be like this. So now -1 angle of minus 1 plus 4j plus 2. Now angle minus 1 plus 4j, angle minus 1 plus 4j plus 1 plus 4j plus 180 degree. Now angle of minus 1 plus 4j plus 2 minus 1 plus 4j minus of my resultant will be 1 plus 4j minus of minus 1 plus 4j minus of 8j plus 180 degree. So minus, how to find out the angles? For this Cartesian system, suppose A plus JB is your coordinate. Now angle will be tan inverse B by A. If minus 1 plus JB, then 180 degree minus tan inverse B by A. If A minus JB, then minus of tan inverse B by A. This is the basic theory to find out the angle from this coordinate particular. Now for this case, minus 1 tan inverse imaginary part 4 by 1. Now for this 180 degree minus tan inverse 4 by 1 minus tan inverse 8 by 0 plus 180 degree. Now plus 180 minus 180 will be automatically cancelled. At tan inverse minus 4, at tan inverse plus 4 will be cancelled out. Ultimately, resultant will be minus tan inverse infinity, that is equal to minus 90 degree. So angle of departure from the reference pole minus 1 plus 4j equal to minus of 90 degree. So let's draw the rough angle of departure, that is from this pole. This is a horizontal plane. Minus 90 degree means negative sides minus 90 degree. So root locus will tangentially go like this way. Now from the property of symmetry, we can say the angle of departure from pole minus 1 plus 4j equal to plus the angle of departure from the reference pole minus 1 minus 4j is equal to plus 90 degree by the property of symmetry. So like this way, if it is your horizontal plane, then it is plus 90 means this is your plus angle 90 degree. So root locus will go in this direction tangentially from this angle of departure. So the next step is to find out the imaginary axis cutting point of the root locus. So from this figure, it is clear the imaginary axis cutting point will be taking place. Now let's find out the imaginary axis cutting point for this particular problem. Imaginary axis cutting point can be found out with the help of route array. For route array, the characteristics equation 1 plus gs, for this particular problem h is equal to 1, then 1 plus gs h is equal to 0 is the characteristics equation. For this problem, 1 plus, if h is equal to 1, then putting the value of gs, that is k divided by s into s plus 2, s square plus 2s plus 17 equal to 0, s into s plus 2, s square plus 2s plus 17 plus k equal to 0, s cube plus 2s square plus 17s plus 2s square plus 4s plus 34 plus k equal to 0. Now s into s cube plus 4s square plus 21s plus 34 plus k equal to 0, or s to the power 4 plus 4s cube plus 21s square plus 34s plus k equal to 0. Now we have to perform the route array. For this particular equation, route array. S to the power 4, s cube, s square on s to the power 0. So let's write the coefficient of the coefficient of s to the power 4 is 1. Drop the next term, then 21 is coefficient of s square. Drop the next one, and next is k. So let's write down the dropout terms, that is 4, 34, 0. Now for this particular problem, 21, 4 will be your key element, and 4 will be multiplied with 21, 34 will be 1 and divided by 4. That is 21 into 4 minus 34 into 1 divided by 4. Ultimate result will be 12.5. So next 4 will be multiplied with k and 0 will be multiplied with 1 divided by 4. That is 4k minus 0 divided by 4, that is equal to k. For the next step, 12.5 will be your key element. 12.5 will be multiplied with 34 and k will be multiplied with 4 divided by 12.5. So ultimately 12.5 into 34, that is equal to now 12.5 into 34, that is 425. So 425 minus k into 4, that is 4k divided by 12.5. For the next term, when 12.5 will be multiplied with 0, the resultant will be 0. So ultimately for the next step, it is your key element, so it should be multiplied with k and 0 should be multiplied with this one. So ultimately divided by this one, that is k. The remaining terms are 0. So this is your route array. So let's try to find out the value of k. For the value of k, the first element of s to the power 1 row should be equal to 0. For value of k, that is 425 minus 4k divided by 12.5 equal to 0. So for the S plane actually, s to the power, first element of s to the power 1 rho equal to 0, that is 425 minus 4k equal to 0, or k is equal to 425 divided by 4. This is the value of k. So for imaginary axis cutting point, we have to write down the equation of s to the s square rho, that is 12.5 into s square, so plus k into plus k equal to 0. It is the equation of s square rho. So it is the equation of s square rho. Why? Suppose for this particular problem, s square rho contains 12.5, next term is k. So the equation of s square rho will be 12.5 into s square, next term, that is s to the power 1 will be drop out, for and next term is s to the power 0, that is k into s to the power 0 equal to 0. It is the equation of s square rho. So 12.5 s square plus k equal to 0. So now 12.5 s square is equal to minus k, or 12.5 is equal to minus 425 divided by 4, 12.5 s square, or s square is equal to 425 divided by 4 into 12.5 minus, obviously, so s equal to plus minus root over of minus 425 divided by 4 into 12.5, that is equal to minus 8.5 plus minus 8.5, right? So s square is equal to minus 425 divided by 4 into 12.5, that is s equal to plus minus root over of minus of this. So it can be written as root over of minus 1 into root over of 425 divided by 4.4 into 12.5. Root over of minus 1 means j, ultimately result of this quantity equal to 2.91. So ultimately s equal to plus j 2.91 and minus j 2.91. So there will be two imaginary axis cutting point. One is plus 2.91 j, another is minus 2.91 j. Now we will find out the breakaway point. For breakaway point, the characteristics equation already we have found out. 1 plus GSHS equal to s to the power 4 plus 4s cube plus 21 s square plus 34s plus k equal to 0. Now differentiate for breakaway point, differentiating with respect to s. With respect to s. So 4s cube plus 12s square plus 42s plus 34 plus dk by ds equal to 0. Now dk by ds is equal to minus 4s cube plus 12s square plus 42s plus 34. So for breakaway point you have dk by ds equal to 0. So ultimately 4s cube plus 12s square plus 42s plus 34 equal to 0. So now try to solve the equation for finding out the value of s. Now for s is equal to minus 1, so let's start. This is the vanishing try to solve by vanishing factorize. Then s of plus 1, s of plus 1, s of plus 1. So 4s square, that is 4s cube plus 4s square, 8s square plus 8s plus 8s plus 8s means 34 s plus 34 s plus 34 equal to 0. Okay, now s plus 1 equal to 4s squared plus 8s plus 34 is equal to 0. So ultimately, now if we further factorize this one, for this equation, if s plus 1 equal to 0, then s is equal to minus 1. If 4s square plus 8s plus 34 equal to 0, by Siddha-Acharya rule, it can be solved like this way. S is equal to minus b, that is minus e plus minus root over b square minus 4 ac by 2a, 2 into 4, that is equal to minus 1 plus minus 2.73j. Ultimately result will be this. So there are three breakaway points taking place for this particular problem. S is equal to minus 1 plus 2.73j minus 1 minus 2.73j.